Okay, welcome back. We're on page 301. Okay, and I was thinking about beginning with a general solution, which would be very interesting, but it's also much more difficult. So we'll just work away here with what we know. The situation is that we're trying to find this height here. Find the height of the column. So let's call it capital C for column. We have a right angle here. So if we want to know the height of the column, either knowing this or this would be good enough for us. We do know, so just think about this triangle here. We do know that this is 30. Okay, and now that triangle has yielded. There's a critical amount of information you need from a triangle. So I'm thinking about this oblique, obtuse triangle here. There's a critical amount of information. It's 3 pieces of information. So indirectly we have those 3 pieces of information. I'm just going to model that triangle here again. We know that this angle here is 120 degrees. This angle here is 30 degrees because it's complementary to this. These 2 angles are beside each other, they're touching each other, therefore we can just add them. They add up properly is what we say. And we have that this is 50. So that means we can solve this triangle. So let's solve it for this hypotenuse. So let's say that the hypotenuse over the sine of 120 degrees is equal to, oh, hold on. Yeah, well, we're going to have to come up here and get this other angle. So it's 30 degrees as well. That's quite a famous isosceles triangle anyway that we know of. So we have 30 degrees here. So in terms of what we're doing is we're doing any side divided by its opposite sine. So we're getting 50 divided by a half. Okay, so we have sine of 120 degrees over 100 is equal to the hypotenuse. So let's evaluate that. Okay, something really fishy going on there. The hypotenuse divided by the sine of 120 degrees is equal to 50 divided by the sine of a half. Sine of 30. Sine of 30 is a half. Dividing by a half is the same as multiplying by 2. Aha, I did this wrong way. Did I do this wrong way around? So that should have been 100 times the sine of 120 degrees. So I'm going to leave this in because you can see I appreciate the challenges that we face. It's all very well, the theory is all very well, but when you're doing problems things go wrong. Like they went wrong for me there, but you also know that something has gone wrong because the scale, the size of the number was just way too small. So I picked up on a mistake I'd made, and that's it, and we go on from there. So we'll just start again here with 100 sine 120. Okay, and we get 50 root 3, and that's exact, so let's leave that like so there. Okay, now 50 root 3 makes this 25 root 3 because you can go half. So we're going to exploit the fact that this is a 60, 30, 90. We could use trigonometry, but using ratios is better. So to go from there to there, it's a half, because you do that on it. On any 30, 60, 90. I'll just flip it over that the way that's facing there. So on any triangle like this, to go from here to here, you'll always half. I'll give you another example. Let's make this 14. That would make this 7, and that would make this 7 root 3. That's how it goes. You can go from the hypotenuse to the shortest side by halving, and you can go from the shortest side to the middle length side by multiplying by root 3. Okay. So of course multiplying that by root 3, we get 25 times 3, which is equal to 75. There's another big component to your exam, and that is speed. Accuracy is great, knowledge, knowing how technique is great, but speed is important too. So doing things like this saves time and gets you through the questions much quicker. Moving on. Okay. Right. So moving on to question 10 now. I'll try and do it on the sheet itself. We have that AB is a vertical 3. Standing on horizontal ground. Just before I do, we should really try to learn something from this question we just did. You should certainly look back and see how we did it. So you certainly want to look out for the idea that when a right angle is included in a triangle, then you're to know to say, well, I know one of the actual angles in there. Okay, and I'm just going to make up another problem that I'd like you to do. Okay, so what we're going to do is we're going to make this length here 100. Rather than go off at 30 degrees, I'm going to shoot up here with 45 degrees in here. Okay. To some height you're ultimately trying to find. And I'll also give you that this is 60 degrees. Okay, that's all you're given. So you're going to get H. Now I'd like you to pause and go to work on that. Okay, knowing that that was 45 meant we could create this outer triangle with 135 degrees here. Okay, and we had 100 here, and if that was 60, this was 30. 165, making this simply 15 degrees if we need it. That allowed us to get the hypotenuse, okay, because the hypotenuse over the sine of 135 degrees was equal to 100 over the sine of 15 degrees. Okay, you can cross multiply in the sine of 135 there to get H, which is ultimately going to go here. So you get 100 times, this will obviously be longer than this, and it's going to be really amped up by the sine of 135, which is the same I think as sine 45, over the sine of 15 degrees. So I'm downstairs already because of the way I pushed the buttons on my calculator, so I'll go down there and get the sine of 15 degrees in, and we multiply by the sine of 135 degrees. Okay, giving me 273.21. Now I'll divide that by 2 to get there, and then I'll multiply that by root 3 to get up here, and you get 236.6 whatever centimeters or meters, whatever way the question is given. Okay, so maybe it's important that we make up extra questions that are quite similar. Okay, and back to this, especially given that they're not using any special angles, I'm going to give a go. This is quite a famous problem, and I'm going to give a go. We're going to challenge ourselves to try and solve it literally. In other words, with just letters. So rather than say this is 12. We're just going to say we'll make this angle here. So I want to. So now, for the first time, we are going to start using letters. So say as in. So we're going to go A, B, C. Now I can't talk, and then on to D. I can't talk about angle D, but I can talk about angle C. And I can say this length is C because it's opposite C. I can say this length is B. I can say this length is D. Okay. Furthermore, I can call this D because it's the only, well no I can't. So I can call it D prime. Okay. And if I've called that B, I can call this B prime. Okay. So the challenge is to, let's call this D and this D prime. Call this angle C. Am I making things very complicated? I probably am. But there is a way of doing it. What we're trying to do is we're trying to figure out this, knowing just that what we do know is this, this, and this. That's all we know. And we're looking for this blue circle here. So let's see how we get on. Let's try it out. You see, we know this angle here, and in our case, okay, this would be 180 minus D prime. Enough of trying to do it literally. Let's do it with the numbers. So we know this angle here is okay, 180. Sure, I could do it mentally, but I want to rest my head for the maths. And maths and arithmetic are kind of two different things, unless it's absolutely elementary. Okay, so I'll put 122 degrees there. I'll come back to the beginning of my calculator where it started off. That's 122 degrees. No, I won't. I'll go 180 minus 32 minus 122 to know that this is 26 degrees. I'm putting in as much information as I can. I'd love to have this, I'd want this piece of information here. I have an opposite pair, and I have another opposite pair that I'm interested in because that will give me this. Okay, so applying the sine rule, let's just call this x. X over the sine of 32 degrees equals 12 over the sine of 26. Okay, that solves uniquely for x by giving us, because we just want to go with catching the light there, fine. Okay, yeah, so we're going to go with 12 sine of 32 close down sine of 26 close and say equals. Okay, so x equals 14 point, well I can't say equals there now because that's not x, so x equals 14.51. Okay, now to go from there to there, I'll just write, because this is a straightforward sine. So the sine is equal to the height, the sine of 58 degrees. Or look, we know that to go from there to there, you multiply by a sine of 58 degrees. So I just want to take my 14.51 and multiply it by the sine of 58 degrees now. Okay, so I'll just go multiply by, and it'll be that answer multiplied by the sine of 58 degrees. Okay, getting that this length here is 12.3 meters. Excellent. Okay, moving on to question 11. So we have a vertical flagpole Fine, I'm pretty much sure we have all the information we need. I'm just thinking about what do they want. Find the height of the flagpole. So that'll be this height here. 45 degrees, the big one, and 30 degrees respectively. Alright, so there's the building and there's the flagpole. Fine. So we only want this height here. Okay, now here you'll notice in these diagrams I'm relying on the geometry far more because these are compounded problems. These are compounded triangle problems where we have triangles inside triangles. So the drawings are playing far bigger role in my analysis and thinking. Maybe. I think they are anyway. So let's get started. So there's 40 along the bottom of a... So thinking about this lower, smaller triangle here, what I have is I have 40 and 30 degrees. So to go from there to there I would get 80. And that has to be good. And to go from there to there I would get 80 over root 3. So you notice you don't need to use your calculator and you don't need to use cosine and sine to get that information done. Okay, because that's double this in a 30, 40, 60. Now the difference between 45 degrees and 30 degrees is 15 degrees. And that'll do me fine. So this sliver of a triangle here doesn't have to be drawn exceptionally well or anything. Just isolate it. Okay, remember the word isolation from algebra. Now we're using a bit of isolation here. And we're probably going to know this angle. Okay, that's supposed to be going straight up. We're definitely going to know this angle. I'm pretty sure. I know this is 15 degrees. We know this is straight through and that this is 60 because this is 30, remember? So that makes this 120 degrees. So if it's not going to fit in, you're